gotta grab a candle lit, cause it's heat through conduction that causes this. Atoms and matter in a fixed position, vibrate when heated like a pan in the kitchen. Transmit the heat energy to atoms next to them that are cooler than they are and cause equilibrium. To even out the temperature, the heat has to travel up the spoon in your tea in the morning with your bagel. It might burn your hand, but just learn the land. Conduction heat energy until you understand. The earth gains little from conduction. It's mostly radiation that helps us function and keeps us warm. It's just another way for heat to move. But now let's move on to method 3 to prove. There are 3 ways that heat can travel. But it can travel in any direction. From the sun it moves to the earth quick as a shadow and disperses in radiation, conduction, and convection. There are 3 ways that heat can travel. But it can travel in any direction. From the sun it moves to the earth quick as a shadow and disperses in radiation, conduction, and convection. Convection is the movement of heat and liquids and gases to even out the temperature fastest. This process is called diffusion. It's a flow of particles cold and hot in a fluid. If you're not listening, then stop what you're doing, cause this is the final mode that heat can move in. And this affects you every day. It's the breeze at your back and the wind at your face. When heat reaches the earth, it rises at a rate with the air in the place, and it moves up till it cools. Trillions of molecules together make up the weather that we see on the news. It's how they measure the pressure of the air and the temperature, but convection is how it got there in the atmosphere. So don't be scared. Heat moves in 3 ways, so we make things clear. It's like there are 3 ways that heat can travel.
Okay, yeah, I think you get that part too.
So conduction is the transfer of heat between substances that are in direct contact with each other. So like when you're boiling water, when you put the pot on the heater, I guess, then touching it, it heats it up. And the better the conductor, which would be the pan, the quicker the heat transfers. So some good conductors are like copper, iron, steel, and some bad are like wood, paper, and air.
Yeah, so if you touch that metal thing right now, your hand will get really hot, because the heat's transferring to your hand. So, and as you saw in the video, it's just contact heat, and you don't really, it doesn't really how it mostly different.
So conduction is direct contact with.
Yeah, and it moves together until it's the same temperature, and it's the atoms, the heat's transferred to the atoms.
Does anyone have any questions on that?
Yeah.
Alright, I do. So how does that connect with the earth then? You guys mentioned some good conductors. How did you tie the earth being heated through conduction?
Well, it said in the video, the rap video, that it, radiation is mostly the heat conductor. So conduction, it really doesn't do that much in the earth. It'll get more explained in a second.
And then convection is the heat transfer, when you.
It's liquid and gases.
When you would turn on the stove, when you turn on a fireplace, the heat will, when you boil water, the steam rises and it'll cool and it'll come back down, and this process will continue and it'll it's a convection current.
Yeah, it's called diffusion because the atoms are they're moving around, they're moving up and they're moving down. When they get more excited, I guess you could call it, the heat rises, and when it's water, if it gets heated enough, it'll turn into a gas and keeps rising until it gets cold, it'll come back down. And this occurs in the mantle of the earth, and it creates weather. So,
Another example of that would be if you have a 2-story house or even a 3-story house, and let's say you don't have air conditioning in the summer, it'll get really hot in the upper stories, and that's why some people put fans in there, because it gets all the hot air out of the house and makes it cooler, because heat rises.
Yeah, and in the mantle, the convection current will move the plates, and so the hot rock, it gets hotter, when it's really hot at the bottom, it's cool, so it sinks to the bottom, and then the closer it gets to the core, the hotter it gets. So then it rises back up, and it can rise, and so when it's like swirling around, there's a diagram, but we're not there yet. But it'll like explain all of it, how like the plates shift because of like the convection currents. Do you guys have any questions about that?
Radiation is a method of heat transfer that relies upon any contact. So like, it's like like a good example of radiation would be like the sun, because it like heats us and it like produces like electromagnetic waves into the air.
There's no contact in radiation. It's just the waves. Like it said in the video that the radio.
Excuse me, did Hannah Edge have other things to go?
On her way.
Thank you.
Like, okay. So like the radiation isn't like conduction. It doesn't have to be in direct contact with it. Like when you're sitting around a campfire, you can feel the heat, and you're not touching the fire. That would be conduction. But radiation is you're not in direct contact with it. Like for the sun, there's electromagnetic waves in space, and then like
Like the sun is so far away, 93 million miles, but it takes 8 minutes. It takes only 8 minutes since the sun is so powerful. It heats everything on Earth. Like we would all die without the sun, because that's what gives us like our main source of energy, and it functions everything from like weather. It like radiation kind of causes conduction and convection, because it gives the heat to cause conduction and convection, and also fires have radiation too.
Another example of the sun giving out radiation on like a warm summer day, when you walk out and then you look straight to the sun, you can feel your face getting warm, and that's the radiation from the sun's light hitting on your face.
And it's naturally occurring because it just really affects all the life on Earth and how everything can function. As I said before, conduction and convection wouldn't happen without the radiation, because it gives the heat to cause those transfers. Okay, so this is kind of like a video of what
ice is at 0 degrees Celsius, whereas C's body is at 36.5 degrees Celsius. The heat from C's body flows through his hand and into the ice, and will raise the temperature of the ice, melting it into water in the process. Here you can see the melted ice on C's hand. In theory, the heat transfer would continue until the water had been heated to 36.5 degrees, but in this case, the water slips through C's finger as soon as the ice melts.
So now convection. This is our experiment for convection. We're using food coloring and hot water and cold water to show you like how convection like transfers the heat. So this is the hot and this is the cold. So we'll put red in the hot. So since it's so hot, you can see the food coloring is transferring to the bottom, or it's just like moving around, really dispersing really quickly since the atoms are really hot and excited. So it's causing it to move really quickly. And see, this one's moving a lot. It's kind of moving fast, and I'm not sure why it's doing that, but I guess it's not cold enough. If it was colder, it would be barely moving at all, but it's not very cold. But see, since this one's so hot, you can see it dispersing like everywhere. And you can see the heat transfer because it's starting to rise back up. So those are the convection currents. It was dispersing, and now it's going back up. And like the way they do it in the video, they took like, I think it was like the egg dye, you know, like the little egg dye things, and they put it in like hot and then they put it in cold. And in the egg dye, when you put it at the bottom, it rose really fast, and then it started to cool off at the top. So it went back down. So, we'll just leave that there, so if you guys want to keep looking at it. Can everyone see it somewhat, at least?
So, you said this was an example of what
Convection.
Does anyone have any questions on the 3D ways of heat transfer?
We have a couple more things, but yeah. And we're just going to show you like the, oh, and this is different. This is showing radiation. There's the ice cube on the sidewalk, and that the sun was melting the ice cube, which is radiation. And then this is just a diagram of how convection occurs in like the mantle. So you can see the arrow moving, and that's like the convection currents they move in a circle. And see like when the convection currents are going this way, it's going to cause a plate to shift that way. But then this keeps going in circles, so it's moving the plates around. And there's like fault lines and boundaries where some is like hotter than others that causes, and there's two convection currents like clashing sometimes. So it can cause two plates to like hit each other, which can it can cause mountain building or it can cause like an earthquake. It just depends on like how the plates collide. Like if they kind of slide past each other, that's an earthquake when it finally snaps. But if it's kind of just like colliding, it kind of packs crumples the plate and it makes a mountain over a long period. Do you have any questions while we're waiting for this to load?
Anything anyone doesn't get?
Any questions at all? What?